Hello students, today we're going to learn section 8.2, another conic section. This one's called the ellipse. An ellipse is the set of all points in a plane whose distances from two fixed points in the plane have a constant sum. The 2 points they're talking about are called the foci, focal points. Key parts when graphing an ellipse will be the foci. Foci is just plural for focal points. The center, semi-major axis, and semi-minor axis. Standard form of an ellipse is written in this manner. The quantity of x minus h over r of x squared plus the quantity of y minus k over r of y squared is equal to 1. H and k is the center, so when you take h and k out of this form, remember it's the opposite number. R of x, again, r of x means radius of x, r of y means radius of y. So we're going to have two types of ellipses. If the radius of x is greater than the radius of y, then what we're going to have is a horizontal ellipse. So a horizontal ellipse when the radius of x is greater than the radius of y. When that occurs, we know the radius of x is equal to the semi-major axis. If r of y is greater than r of x, then we have a vertical ellipse, a tall ellipse. So the radius of y will be considered the semi-major axis. And to find the focal distance, we have the formula c squared equals a squared minus b squared. Note that a will always be the semi-major axis, b will always be the semi-minor axis. So it depends on the radius of x and radius of y to determine which is the semi-major and semi-minor. C is the focal distance from the center to the foci on the major axis. Again, C is the focal distance from the center to the foci on the major axis. Okay, so let's try number 1. Here is number 1. I want you to label the center, foci, semi-major, semi-minor axis, and which conic we're dealing with. Write the equation in standard form and graph. So when we write in standard form, we have to complete the square. So here's the first example. We have this equation. So what I need to do is I need to group all my x's together and all my y's together. And at the same time, take the constant and move it to the right side of the equal sign. So I subtracted 184. I grouped all my x's together, 25x squared, negative 200x. Grouped them together. I'm starting to complete the square here, so I put a blank space here. Group all my y's together, 9y squared plus 18y plus another blank space equals negative 184. So in order to complete the square, the coefficient of the quadratic has to be 1. So what I'm going to do now is I'm going to factor out the 25. So I'm going to factor out the 25. So I factored out the 25, and I'm going to factor out the 9. Okay? So when we factor out the 25 and we factor out the 9, the coefficient of x squared and the coefficient of y squared is now 1. So from here, I'm going to complete the square. So we take half of our linear coefficient and we square it. Half of negative 8 is negative 4. Negative 4 squared is 16. I'm going to put 16 in this blank space. Now, if I change the left side of the equal sign, I have to do the same change on the right side, so I have to balance the equation. I did not add 16 here, I added 25 times 16 because we have 25 times 16. So again, we have 25 times 16 on the left. We have 25 times 16 on the right. We'll complete the square here. So half of 2 is 1. 1 squared is 1. I'm not adding 1. I'm adding 9 times 1. So again, this is 9 times 1. So 9 times 1. We have now completed the square. We'll simplify the right side. And now we have this equation. So when you multiply and add and subtract all this, you get 225. X minus 4 squared is equivalent to x squared minus 8x plus 16. Y plus 1 squared is equivalent to y squared plus 2y plus 1, because now this is a complete square. Now, standard form means that we have to have the right side equal to 1. So what we're going to do now is divide by 225 in every part. So I divide 225, divide 225, divide 225. Next, we are going to simplify. So 25 over 225 is 1/9. 9 over 225 is 1 over 25. And 25 divided by 25 is equal to 1. So this line equals this line. And this is now in standard form. Remember, standard form was here. This is now in standard form. Now we're going to label all parts from our standard form. The center is opposite -4, opposite +1. So the center, 9 can be rewritten as 3 squared, 25 can be rewritten as 5 squared. So this is now in standard form. So the center is 4, -1. Remember, when you take these numbers out, it's the opposite to get the center. The radius of x is 3. The radius of y is 5. Therefore, we know that the semi-major axis is the radius of y, because the radius of y is greater than the radius of x. So if this is the semi-major, this is called the semi-minor. Next, we have to find our focal distance. Focal distance, the formula is c squared equals a squared minus b squared. We already said that a was 5, b was 3. Simplify everything, and our focal distance is c equals 4. So this is our focal distance. And again, that's the distance from the center to the foci. Okay, so let's start graphing. Let's plot the center for -1. For -1 is right there. There's 4, -1. After we plot the center, we're going to plot the radius. So the radius of x. So radius of x, we move left and right. So it wants us to go 3 units. So this is 1, 1, 2, 3. And this is 1, 2, 3. Next, we're going to do the radius of y. The radius of y is 5. So from the center, again, this is the center. 1, 2, 3, 4, 5. From the center, 1, 2, 3, 4, 5. Okay, so now let's form our ellipse. So there's our ellipse. So that's our ellipse, and it's a vertical ellipse. It's a tall ellipse because the semi-major axis will be the radius of y. Next, let's plot our focal point. Let's actually first, let's do this. Let's label. So that's the radius of y, and that's the radius of x. So here is your semi-major. This is the semi-major, and this is your semi-minor. Remember, semi means half, right? So this is your semi-major, this is your semi-minor. Next, we're going to plot our foci, our focal points. So C is the distance from the center to the focal point. So here's the center. And the focal points are always on the major axis, never on the minor axis. So I know that I'm going to count 4 from the center. 1, 2, 3, 4. There's one focal point, and that focal point is going to be 4, -5. So there's one focal point. And from here, we count 4 units, right? 4 units. So from the center, 1, 2, 3, 4. And this is going to be 4, +3. That's our other focal point. This is an ellipse. And did I label everything? Yes, the radius of semi-major is here. Semi-minor is here. We labeled the focal points, we graphed the ellipse, and we labeled our conic. So this conic section is the ellipse. All right, and we can go ahead if you want to put semi-major, and then this is our semi-minor. All right, so that is example 1. And again, go ahead and make this darker. Okay, so semi-major, semi-minor, our focal points are labeled, ellipse is labeled, and we graphed our equation. All right, so that was example 1. Next, we'll do example 2. So example 2, here is example 2. Again, we got to group our x's and y's together and move this constant to the other side of the equal sign. So I'm going to subtract 324 on both sides. And then I'm going to group all my x's together, group all my y's together. After that, the quadratic coefficient has to be 1 to complete the square. So I'm going to factor out a 4 from here, factor out a 36 from here. Okay. So now we factor out a 4, we factor out a 36. Now that the coefficient is 1, what we're going to do now is complete the square. So we take half of 12, we square it. 6 squared is 36. So I put 36 here to complete the square. And remember, now you're not adding 36, you're adding 4 times 36. So I have to balance the equation and do the same addition on the right side. Half of 6 is 3, 3 squared is 9. So now this is 36 times 9. 36 times 9, this is 36 times 9. So I'm balancing the equation. Now what we have is we have a complete square. It's written in squared form. For this to be in standard form, we have to divide this by 144 because we need the right side to equal 1. So we divide by 144, both the right and the left side. We reduce this, reduce this, reduce this. So 144 divided by 144 is 1. 36 over 144 is 1/4. 4 over 144 is 1 over 36. This is not in standard form yet because I don't have this squared. Now it's in standard form because all of this is squared, all of this is squared equals 1. So again, going back to standard form, that's what it is. Radius of x, radius of y is all in the parentheses, squared equals 1. All right. Now what we can get from here is the center, the radius of x, radius of y, and then we could find our focal distance. So here's the center. -6, 3. -6, -3. Remember, it's the opposite. The radius of x is 6, radius of y is 2. Therefore, this time the semi-major axis will be the radius of x. Semi-minor is the radius of y. Focal distance is the formula here. We already said A was 6, B was 2. So after we calculate everything, C is approximately 5.7. So again, C is the distance from the center to the focal points, to the foci. Now we'll graph. So the center, -6, -3. -6, -3, right about here. Actually, it is here. So -6, -3. Now we have to count the radius. So remember, radius of x moves right to left. So from the center, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then radius of y moves up and down. So from here, 1, 2. And from here, 1, 2. Well, now we have our ellipse. Now this is called what I call the horizontal ellipse. Or you could say long ellipse if you want to describe it. But again, I like to use the word horizontal ellipse. Because you're relating it to the horizontal, which is the major axis here. Okay, so that is our ellipse. Now what we have to do is we have to, remember, we have to label all the other parts. So they're asking us for, what else? The focal points, right? The semi-major axis, semi-minor axis. So I already know here, this is your semi-major. Why? Because it's the longest side. Here's your semi-minor. Okay? And now let's find our focal points. Remember, focal points are always on the major axis. So since C is the distance, we'll just go 5.7. So let's count. 1, 2, 3, 4, 5.7, right about here. Okay, so now to calculate that, since the center was -6, -3, all we do is we take well, we know this is -3. That's the y-coordinate, but to find the x-coordinate, well, all we do is we take -6, and if we went -5.7 in this direction, this is now -11.7. So -11.7, -3 is our focal point. We went -5.7 in the left, so that means -6. Add -5.7, you get -11.7. Here, we're going to go 5.7 in this direction. 1, 2, 3, 4, 5, and let's say it's roughly here. So here's the other focal point. So this is -6 plus 5.7. So -6 plus 5.7 is, so -6 plus 5.7, -6 plus 5.7 is -0.3. So -0.3 comma, what is the y value? It's -3. Okay, so there are the two focal points. The center, I labeled it here. This is your semi-major, semi-minor. And again, the name of this conic is an ellipse. And it's actually a horizontal ellipse because, again, it's long versus vertical ellipse is tall. All right, so that is it for the conic section ellipse. Please just make this a little bit neater than what I have it. All right, so that's it for today, class. Have a good day.